we'll start with Arduino libraries. So, does anyone know what libraries are? I mean, people who are familiar with coding and programming, they obviously know what they are.
I missed out on whatever you all said until this point. What did I miss out on?
We just started. These
We just
libraries today,
started.
Arduino libraries,
Is it where the data is stored?
not really.
Can we say it is like
They store the
pre-
functions.
it is like a
Kind
predefined
of.
collection of programs or functions which we can incorporate into our own program so that we don't have to like make up the whole code from scratch again. We can
Yes,
just implement
absolutely.
what has already been.
That's correct. These are pre-written codes written by other people, which we just copy from them and use in our own projects. Like, did they do the work for
Basically,
us?
we did.
What? Okay. So, libraries are basically pre-written codes which we install or they're already installed. We just use them in our codes. Some examples of those libraries are given here, like Ethernet library, which helps us connect to a network. Touchscreen library, which you have seen, helps us write on screens for drawing, playing, etc. So, did you understand what libraries are? The basic function of library.
Yep.
What
Yes.
exactly are they? They are not something you store data into. Those are not libraries. So let's proceed now. There are three different types of libraries right now. Standard ones, library manager libraries, which we will teach you how to install and do stuff with. And others are user install libraries. So standard libraries are the most basic libraries, which are pre-installed when you install your IDE. And some of them are like controlling the servo motors, which we will teach you today, actually. So these are the libraries you don't have to install from anywhere else and you'll get them by default. Next library is library manager libraries, which you have to install from the IDE itself, not from anywhere else other than the IDE. We will show you how to install from the manager itself. So don't worry about that. And the third one is user install libraries, which these libraries have to be installed externally and you will not find them in the IDE. So like it's given, you have to find them from GitHub or Arduino Playground. So does anyone have any doubts on these types?
And
Did you understand what types do?
Yes, sir.
yes.
Absolutely.
Yep.
Okay, so if you have your IDs nearby, or I mean, if you are doing on the device that has the ID on it, open it right now. It will help you. So first, we will teach you how to install libraries from the library manager given in your IDE. So there are actually two ways, but it's stated only one here. So first way is to go to Sketch tab. Beside tools is the tab which you use to set the port. And so the Sketch tab has a include library option, which allows you to actually include the libraries you have installed to your code. So you will see the manage libraries option, which you can also open by the shortcut. Another one is in the tools tab where you can actually directly find the manage libraries option. So it's basically the same thing, nothing different. So uh, those of you are doing it right now in your IDE, complete it and maybe open it. Okay, so I guess it's done now. So when you press the library manager option, this dialog box will open. It's like this is not full screen. This will be a small box. You can move it around. You will get the search bar here, topic and types. For this, we will do servo motors currently. We will need two types of, or rather just one. There are two versions of that library. You need to type in AF motor in the search bar. You get two types of Adafruit motor libraries. You have to install preferably the first version. If you want, you can also install the V2. Depends on you.
Should always install the first one, and if you want, you can go the second one too. Okay, but always keep the first one installed for at least this project.
There will be an install option here. I have already installed, so it's showing installed right now. So you can take a screenshot of this maybe if you want. You can remember them. So those of you are doing it right now, try it.
So we installed the first one, correct?
The first one, I don't know, it may depend. Like first one shows V2 and the second one shows just library. So just install the one that doesn't show V2.
I rather install both.
It's completely fine if I install both. Just for safety measures, always just keep V1 with you. Okay. V2 is optional, but it's preferred in some cases in the future. Actually.
On my device, it is showing already installed the Adafruit first version 1.
Then it's fine. It's fine.
Let's proceed. After it shows installed there, you don't have to do anything, just press close. Here with close button, just press close. You won't have to restart the ID or anything. Then go to the sketch tab again, include library. Now we have to include the library that we have just installed. So you need to scroll down to the recommended libraries. You will find the Adafruit section, and you have to install the input the Adafruit motor shield library. You have to do the version 1. Like you can do the second one as well if you want. I don't recommend doing it both together. You have to put one, and as soon as you click it, this line of code will be put into your code, and then your library has been installed. If if these options don't show, that means there was some error installing the library and you have to redo it. So did you understand how to install it?
Yes,
Did
yes.
anyone try?
I did.
Hmm.
Did it work?
Hmm.
If you have any doubts or any problems you're facing, just contact us. We'll help you. Okay, so I guess that's all for the theory for this class. Now let's proceed with the practical part. Now Divyesh will show you some things you can do.
Yeah, so we will be using this code as the reference for our model. Yeah,
Okay,
that's it.
actually you can just take a screenshot of this code written here,
No, no,
or
no, no, no. Don't just interrupt this exact one.
I have to.
So you know what? You know what? Let's skip this. Skip the code. Stop the screenshot. We don't need it. Okay, so let's get started with the practicals. So I'll just turn on the video, okay? And guys, please tell me if the video is clear at this time. Okay, you guys can you guys pin the video which is up right now?
Are you operating video from mobile? Yeah.
Yeah, why?
No. Just saying.
So let's get started. The one thing we did not teach you guys in the PowerPoint today is motor shields, or in this case, a motor shield. So what I have here is, you can also call it an extension for the Arduino, because, okay, so take a look at this. This is a FM9 3D model of my motor shield, okay. This basically helps your Arduino communicate with these DC motors, which we'll be working with today. And there are other types of motor shields too, like infrared motor shield, and one we taught you guys in the example for like touch screen motor shield, stuff like that. We'll learn about it in another class, but today we will be working with these motor shields. Okay, you guys can find the LM29, I think it is 9S version. Like it's a bit shorter, that's why I recommend you guys buy this current version. We'll be sending you guys the Amazon link for this and the DC motors after the class, so just keep an eye on the server for that. Okay, so let's get started. The reason why this shield is called an extension, because very simply put, if you take your Arduino, just put my cable, you can just very easily put it on top of your current Arduino, just like that. Just like that, and you just press it down, and you have your motor shield installed. Now, you guys remember how in the beginning of the class we did the how we learned to install libraries? We installed the libraries so our Arduino can
Yes.
work with this motor shield. Give me a second. Okay, sorry. So we'll be learning on how to operate motors of a motor shield using an Arduino. Okay. So my main concern for you guys is to buy these DC motors and this motor shield. The motor shield will cost around, I think it's $399 or $299, depending on where you buy it from. Doesn't really matter for the quality that much. Buy the motor shield, just clip it on. It's that easy. Okay. Don't worry about it like breaking or something. It should clip all the way in. Okay, all the way in. No extra gaps or something. So what these pins are for, they're basically the extension of these headers in the Arduino. You guys can solder pins onto this yourself for the analog outputs. I'm not doing it right now because it's a bit of a lengthier process. So what I'll be doing is I'll be working with these pins. So you guys can see that I have 3 modules. I think video 4. Yeah. So basically we have 3 modules here. This module and this module both conduct one servo, two motors from here and 2 motors from here. So each chip will work with 2 motors from this side and this side. And the notation for these motors work as this is port number 1, this is port number 2, this is port number 3, this is port number 4, or it can be different in your motor ability, but it won't matter that much because today we will only be working with these 2 ports or just one single port if time permits. Okay, so let's get started with how to connect the DC wires to cable. Now the wires the motors that you may buy may not come pre-installed with wires, as it's not really pre-installed. I soldered them on. So that's the reason for current one. That is, how many of you guys have experience with soldering wires onto motors or servos onto wires? How many of you guys have experience in that field?
Not to mention.
I beg your pardon.
Right now.
How many of you guys have experience in soldering?
Right
From
now.
last
I have
year?
experience.
Right now.
Okay, can I ask who this is? I cannot see the face of that. It's my name actually. Pranash, yes. Right.
Yes, sir.
Okay. So I think majority of you guys don't have that much experience soldering. Okay.
I also have experience.
So I think it's in my best interest that I teach you guys how to solder. Do we have time for that? Yeah, we have time. So just a quick intro to soldering and just very quickly. This is a soldering iron. You guys may have seen this before. I won't say
Yes.
yeah, this is very dangerous. Like extremely dangerous. Trust me, I know.
Actually, I
And,
also
yeah, I think
dangerous.
anyone
It can
who has
pierce
done
a hole into a
soldering,
shoe, so
yeah,
it is dangerous.
yeah, we're definitely not speaking from experience.
I also accidentally touched it
Yeah,
while it was
I think
warm.
anyone who
I
has
got
done
burned 3
soldering
times.
knows the perils of
Few
doing
people
such as
touched it.
Yes, but it's
Yeah.
not that much unless you
put
Unless you
it
really
uh,
put your hand on
No, 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 no. Don't try to touch it
no,
again there.
unless
Please
unless
don't, please
you
don't, please
put
don't.
your hand for a long time.
Acha, one more thing.
Okay, don't try.
The soldering kit I would recommend you guys to buy. I'll just send it in the Amazon. It should look something like this box right here. Okay, it will come with the soldering iron, and the major reason I
This is
recommend this.
exactly what I bought.
This
Me
is
too.
exactly what Ankita gave us last year too. That's the thing. So the thing why I recommend this is because it comes with these tweezers. And these are extremely useful when working with jumper wires. I use them myself for cutting the jumper wires and splitting out the ends. And of course, this thing is the stand for the soldering iron. And if you want to be really surgical, you can use it. I don't use it because I don't need it. And of course, the soldering wire. It's actually really, I don't know how to use it. Anyway,
Acha, what is
And
that
as
syringe?
a warning,
I never
don't
got that.
touch
What
the
is that
what is
syringe?
that?
soldering
What is that?
to the wire.
Yes,
What? No, the syringe. Syringe.
inch. Yeah, I have no idea what this is because I don't use it. That's why.
It
I
is a
also never
You
desoldering
got
don't
that.
pump.
really need to use it. It's
It's a
like,
desoldering pump
yeah,
actually.
I think you will put this stuff, the desoldering, wax, soldering flux. Sorry, this is the desoldering wire. I don't think it's for the flux or something. I don't know. I don't
Pump
really
is
use it.
harder actually.
Yeah, I don't think you guys will really need it because we're not going to be desoldering unless you guys are really into that stuff. I
Acha,
won't
we
recommend
can
it myself.
also make a soldering iron at our home.
Yeah, please
Using
don't.
a.
Please don't.
No, we can.
No, don't. I'm telling you, please don't. Do not try to mess with this soldering stuff uh, on your own, like
No,
making stuff
make a
like that.
soldering iron at our home.
That is a
And
very bad idea.
Like using a
do not
pencil.
Very bad
make
idea.
do not make these industrial equipments at your home unless, yeah, I don't know. Just don't.
Unless you are a scientist here.
Thing could blow up in your hands and then,
More like it will just
Yeah,
melt
this
your
is
hand.
not to be stressed.
No, why it would blow up in my hand?
I'm setting this stuff up. It's just the first time setup. You guys should do that too. If you guys have water.
Looking at the setup, I believe it's going to cost a fortune.
Yeah, sorry. Can you repeat your question? Can you repeat your question?
Is it
So,
expensive?
Not really, because I bought this because it was extremely cheap, and I basically recommend this for these pliers. They're extremely good actually, like to chip off the heads of these jumper wires and stuff. They're extremely useful. I'm teaching you guys how to make these wires yourself today actually, because we have time, I think. Okay, let me just start off with how to connect a DC motor with these jumper wires. Okay. So I'd recommend you guys can get any kind of jumper wires, male to male, female to female, male to female. It won't really matter. I just need this wire. Okay. So what I normally do is the reason I bought this was this pliers just cut them off the headers of these things. Maybe female, maybe male. Doesn't really matter. So you
And we
can
can just use any kind of wire.
yeah, but I would
As
recommend
long as it's
using
hard
this
enough.
jumper wire.
Okay.
I'd
So what
recommend
is
using
that
using
male
this.
to male and female to female again?
You guys
There are
have bought
types of
the
jumper
sets of
wires.
jumper wires, right? Yeah, so you see,
And
this is a
what is this one we are using that we
very
use?
fun. This.
There are three types actually: male to
No,
male,
that is
female,
jumper
female to
wire.
female.
Yeah,
That
jumper wire.
what which jumper wire is we are using right now?
It doesn't really matter. You can just cut the heads off of anything and it will just give us this wire. I just need this wire without the headers. So I can connect them to the series terminals. Okay. Isn't really that complex to flick the wire that you like or anything that exists. Okay, so what I need now is for the copper to be exposed from this rubber. So what I do is I just chip around this end in hope to get the plastic off, applying just the right amount of pressure to eat into it. Again, this is just a trick I use, just a trick I saw, but I like to share it myself. Yeah, that's it. Okay. Give me a second, I'll just check this out.
I think you have to cut it through the groove.
Yeah, I am. There is no groove. There is no groove actually. You
No,
can put
that
it
group with that.
this groove, right? This groove,
Yes, I
right?
think you have to cut it.
Yeah,
Yes.
this groove is for the HDMI wire only. You just cut off the entire wire if I just put it like this. You want to see?
Oh, okay.
You just cut off this, put it in the groove, and you just cut off the entire wire. That's the problem. Trust me,
Yeah,
this tool
understood.
is extremely useful. Just why, like, trust me, you won't. Okay, and once you have enough of this part cut off, just twist, and it should break off the rubber, and just twist until it comes out, so you have a nice pointed edge which you can use for soldering. Okay, that's how I usually use my jumper wires for connections. If you think it's too complex or it's too time consuming, by all means try it for yourself. You may find other ways to do it. Doesn't really matter to me that much. Just don't cut off the entire jumper wires with too much force, because that is what I have been doing a long time. And
Why not
it's,
kitchen scissors?
It would
I don't
eventually
trust
cut the
kitchen
whole
scissors.
wire, sir.
We can use paper cutters also, but I think that will take a
Paper
lot of
cutter? No, no,
time.
no, no. That is
Also,
too much time.
Also I cut my hand.
We are really experienced with all those. Can
In that situation, you can always
Yes.
use your teeth. I mean, that's the most efficient way.
And just
that's the cheapest way actually.
You must have seen your local electrician do that.
and the best way to pull off this rubber is not just pull it. I will let it twist it. Okay. So the wire which comes out is twisted, and of course twisted pins and straight once. That sounds good. Yeah, and the wire should just come out pointed like this, which actually makes it easier to solder, because if you just pull it out, it will have frizzes at the end. So it makes it really difficult to solder it on. Like this one, I didn't twist them out. Sorry, these ones, and you can see that they're frizzed at the end, which just led to this horrible solder. Okay, so just don't do this mistake that I did. Make sure you guys do a quick go. Okay, so I want to teach you guys how
Use
to
as
solder.
less solder as you can.
Yeah, exactly. That's good. So I'll just be teaching you guys how to solder one end, because if you guys know how to solder one end, then easily solder the other one. So at this point, after I usually get my wires in order, I now try to plug in my soldering. Hopefully it won't fall on me.
Are you guys understanding how it
Not a keyboard way.
Yeah.
This is not something to, it's just to
Yeah,
observe and
research.
learn. Visual learning.
that then anyone
Okay,
comes up
so I
can
have my
decide to
soldering
cut the
iron
whole
plugged in.
wire?
Hopefully it hasn't gone bad, because the soldering iron. So what I do with this soldering wire is just cut off the topmost end, because that's just the view I have, and I'll go like that, and pull out like 2 or 3 inches. Okay, not too much. I try to keep it straight because it is with the working with right now. But I think my iron is hot enough. Okay. The reason, okay, now take, you will see if you buy these exact DC motors, you will see that there are pinholes at these terminals to pass wires through. Okay, so that's why I recommend buying these, because you can just pass the wire very easily through there. You can see, and just give it one turn to secure its position. I think my iron is burning up. I'll just check this.
Can you please move your camera towards your hand a bit more because I can't see it.
Question is, can you move your hand? Because if I move my camera, my phone will just fall flat on my iron. Yeah, that's it. You basically just want to attach it very loosely. I prefer soldering with my right hand because I have more control over there. I'll be pulling this towards this side because I don't have that much wire. Okay, okay. So what you guys don't want to do is put your soldering iron on the wire. Okay, you don't want to do that. You want to put the wire on your soldering iron. It's really hard to see, isn't it? Okay. So you guys should keep your iron above the wire as a heat source and use that to melt your metal, the solid metal, because the alloy, onto this wire so that it melts on it and forms a secure bond. Okay. So just like that, keep the iron above the wire, and push the wire and push the metal into the iron so that yeah, you see, it's a perfect solder. Perfect solder. That's it. Okay, now let's just pull out the soldering bar because it's extremely hot. Okay, now you guys can see I got a very shiny solder over here. The way you can just can't do it that way because the heads are directly connected to the copper and it is basically just severing the connection entirely. It's okay to
Okay.
like look at this. This is the head I pulled out for this wire right here. You can see that there's the wire protruding out from it. That's the header. The copper is connected directly to this head. Right to this head. That's why if you have cut the head of a jumper wire, it's just cheap wire at this point. Okay. Don't really worry about it that much. It's okay to lose a few jumper wires here and there. That's why I told you guys to buy in bunch and reuse them like these ones.
Okay.
Okay, so now I have connected my DC motor to my shield. Just put a light tug on these wires. If they don't come out, that's it. Do not pull too hard and do not push these screws in too much because they may just get jammed in there. That's a bit random information, but still, I need an extender. And we can run this motor off of a 9-volt battery, or you can just plug in the USB to it and drive off your PC. I prefer running it off the USB for this project. Fortunately, my PC is a bit far away today, so we'll have to manage. Yeah, this won't work. Give me a second, I'll just get my extender. Is this fine? Will this be a problem? Is this too much of a problem now? I hope you guys can see very well what I'm doing.
Yeah.
Okay. So when I've connected my Arduino to the USB cable, you will see that the motor shield light is also lighting up. And one more thing, you see this little yellow cap right here? This yellow cap. This is a jumper for when we are connecting the motor shield to an external power supply. That is, in this case, a 9-volt battery. I'm not going to connect the 9-volt battery this time because it's just useless right now, and this requires my power anyway. So you will keep this jumper on when you want the Arduino to be running off of that power from the USB, and you will just pull this jumper off if you want it to be running off of the power, the battery. Okay, it's just a thing I'd like to tell you guys. Was a reason
I
why.
missed the whole bit about attaching the DC motor to the Arduino because my net said bye bye. Could you please go over it
I
again?
can. What was this? I think I can repeat. I don't hear it properly.
The entire bit about attaching the
Acha.
motor to the Arduino, yeah, I missed that
Okay.
because net said bye.
So the DC motor which I bought, it said in the box that this side is the positive terminal, this side is the negative terminal. So in that rotation, you have to put these wires into either of these 4 ports. Okay, and there are 2 more ports on this side, as you can remember. In one of these 4 ports. Okay. So in total, this extension can only in total support 4 entire DC motors. Okay, and I'm using this one because it is what is currently known as the first port, and it is going from there. And so the first because it is easier to code with the first port, and just take the wires off, take the wires away from the DC motor, put them in to these 2 keyholes and screw them in. That's it. Don't screw them in too tight because it may be hard to get them back up because these screws are actually very flimsy and the head of the screwdriver, and you just scrape them off, and it may become very difficult to get it out again. Just push them lightly in. As soon as you feel that there is a hindrance for these screws, just stop. Okay, that's enough, and try to tug them a little bit. They shouldn't really come out. Same for this one. If that's it, your remote is connected. Good job. Okay. Now that we have connected the motor, I'd like to start off with the code. I hope, do any of you guys remember the code we showed you guys at the start of the meeting? Hello.
No.
No,
That's
not
good.
me.
That's good. That's good.
Okay,
Because you're not supposed to.
I'll screen share maybe.
No. Question.
Okay, okay.
So I think I should start off with showing you guys how I wrote a code. Okay. Let me just open my folder.
Can I use another screwdriver for fixing the screws instead of the
Then
pre-installed one? Or is the
this is my personal screwdriver. I bought it when I was like 2 years old. I don't remember.
so
You
any
can
screwdriver
you can
works,
use
right?
any kind of screwdriver to drill this screws in. You don't need
Anything of the medium's perfect size.
Okay, I think issues I cannot really work with my phone right now. Okay, so it's not really possible for me to show a video demonstration today, I think. Very sorry about that, but yeah, problems like this can't be avoided really. Instead, I'll just be showing you guys how I wrote the code, okay? Will you guys be okay with that? It's not really such a difficult concept for the working for it. You guys can visualize it. You guys can visualize it yourself, okay? Are you guys fine with this? With one of these things right now?
Yeah, yeah.
Sorry for this thing today. Okay, can you guys see the screen as of now?
Yeah, yeah.
Yes.
So here are the code which will make the motor run and then stop running and then run again. Okay, it's a
What
very
is
quick
that file
definition.
name?
Ignore. Please ignore. I wrote this at like 2 a.m. yesterday, please. Anyway, let's start off with how the code is working. So first, I'm including the library of the AF motor. That is if I go into Sketch, include library.
I had a doubt.
Yeah, go ahead.
So I was seeing the example sketch, and beside this part of the code, where we are defining the object if a DC motor, they have also put a frequency like 64 kilohertz and 8 kilohertz. So do we have to do that also?
I think that's a delay function problem. I don't think so. I'm just giving this you guys the code as a reference point. You will be writing your own code later after this. Don't use this as like some sort of
No, I was
um,
just seeing the example sketches now. So in all of them, they have put a frequency beside the AFDC motor objects.
Jonathan. Yeah, I heard about that.
Okay.
So this will not be one system motor. So here I am defining that I have a DC motor connected to my first motor port. That's if you guys remember, the shield had 4 motor ports, 1, 2, 3, 4. I have told it to connect to the first one. Okay. Now void setup. I am setting the speed of my motor on 225 for these Adafruit motors or Adafruit shield. The maximum speed your motor can go is 255 and the lowest is 1. Okay. And 0 is just stop. And I am doing this to give it the function that my motor will now be running on my commands. Okay, anybody have any doubt till just for void setup? Why have we done
No,
motor speed and why?
No doubt.
Okay.
no doubt.
Now void loop, which was I want this code to run in a loop. So motor run forward, delay 300, 3000, and motor run release delay 500. Now what I mean by this is motor dot run is like what I said again. It is like digital dot write. So motor dot run is the function we'll be using to tell the motor that you have to spin in this order. Forward is also reverse of forward is backwards. you will know that you have written the correct function if this lights up in this tree color. If it does not, you will in the one in this field. You get to forward and we have a delay of 3000. That means I want the motor to run in the forward direction for 3000 milliseconds, which is how many seconds? Does anyone know?
3 seconds.
3 seconds.
Actually, very good. So it's that I want the motor to run forward for 3 seconds, and this release function is to override the code above, to override line above, and to stop the motor from spinning. And I have given this a runtime of 500, which is half a second. Okay. So unfortunately, I don't have my camera, but if I, yeah, it is
So it will
possible.
run for half a second for every 3 seconds.
Close, close, close. It will actually run for 3 seconds, then stop for half a second, then run for 3 seconds again.
Also, we can also buy a fan blade, a small fan blade to see
Sorry?
whether they're running or not.
No, no, no. The
What
motor
is the
is a fan.
maximum speed of the fan and can we adjust it?
The maximum speed is 255, and in the void setup I've written motor.set speed as 255. So I can write this as 100, which will make the, well, it's not really a fan, it's the motor, it will make the motor run at a speed of that is 100. I'm going to don't know if it's RPM or RPM or
I
RPM,
see.
Also, that is RPM.
I think so. Pretty sure it's RPM. And depending on the motor you have, it may be faster or slower. It may just be a value like constant or something. Doesn't really matter. The speed won't really matter for this project that much. Okay, so I just in 1 minute. I'd like to really wrap this up very quick. So does anyone have any doubt with the code that I've written?
So that one, that a motor, that library we have to install. That one we will download that DC one or that first one.
First one actually has for the motor and this other not the server is built in right now. Yeah, just
And
this
I
is
will
Ananda.
download the
Yeah, just as
motor
Ananda
shield
told,
instead of the V2.
you can download both. That's what I'm saying. You would manage library and then just search over your Adafruit, as I told you before. Go to open up now because that's basically you can download the Adafruit library and go to Sketch include library and scroll down, click on the Adafruit location library, and it will again include the same library here.